Hello my friends, welcome to Institute channel. This is Uncle Misha, and today we have something, unusual or something very interesting to me, but it is probably unusual. This is bad, not supposed to be. Anyways, this is Creality LD-002H 3D printer. Alright, it's a bit beat up, so I got this thing broken. It sort of works and sort of not. So device itself working, okay, but the display screen, which actually is supposed to project an image into the resin, does not. So today we'll take a look what is going on with this guy. All right, looks like fab film is actually in a rough condition as well. All right. Yeah, as you see, this thing is pretty big and barely fits the workbench, but when we get to electronics, I don't think it's going to be that big. So let me power it up. I probably can power it up in this kind of horizontal condition. Obviously the power cord is positioned in such a way that I won't be able to show you it's operational. And okay, it's booting up. Okay, system, back, tools, manual. As you see, it actually does work. I think it goes by 10 millimeter, 1 millimeter, 10 millimeter. Okay, so at least the board works, the display works, touchscreen works. So all this is operational. So they're gonna take a look what's going on inside and why this display. Let me remove this. I don't know really. Why this display is not showing through. You see, it's actually, you see the LEDs, but if there is no image, so essentially the display doesn't work. It just shines through the masked display. All right, so exposure has ended. So LEDs, at least LEDs works. So let's remove the VAT or whatever it is. I think that's called VAT. It's quite beat up, so we have to probably replace it. Yeah, it's an interesting procedure to do so, but anyways, that has to be, wow, it's kind of sticky, so that has to be all cleaned up. It's like a, by the way, this it's a little drum here, right? Okay, so here we have the display. So this is probably the Z sensor. So this is like for homing. This is a little fan, I don't know what the hell it's doing here. Change the screen where power is off. Well, I mean, sort of kind of makes sense. So yeah, clearly we have to like disassemble the thing and see where we are. Okay, so after investigation, a little bit investigation, I figure out that I have to actually open the printer just like this. So this apparently gonna be an access to the board. Let's see what we have here just right away. Here we are. So this is our board, and this is a little LCD connector. Okay. So this is running STM 32F4 processor. Pretty beefy. So this ribbon connector is for front screen, and this ribbon connector is for masking screen. Okay, there is a Wi-Fi connector, very interesting. There is a serial connector. I don't know what that EXTZ means. This is a reset button of a sort. What else do we have? What is this connector? So there is one connector is connected, another connector is let me pop this. Pops super easily. Let me examine this connector if it's like okay or not. Okay, so I don't think I I don't think I'd understand what's really going on here. So, and probably my main solution would be to actually completely take apart all this jazz, get access to the board, to the display, maybe even pull it out of this box. Essentially, keep it the board. I can power it with external power supplies, no problem. You know, detach the LCD and other paraphernalia just to make sure, and probably not use the ultraviolet LEDs, like disconnect them. Just because I want to understand if this little MIPI connector, which actually has 50 pins as far as I understand, it's really hard to calculate, I think it has 50 pins, is actually, oh yeah, it says here 50. It's like 1, 2, blah, 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 50, 49, 49, 50. It probably goes like 1, 2, 3, 4, 5, 6. It's very interesting pinout, which is stupid, by the way, but still. Yeah, so the same pinout is right here. It probably gives me, it'll be much easier to measure stuff, so I have to completely disassemble all this. So let's just do it. A lot of screws around. And here, under disassembly, we have to understand and measure all voltages, because essentially, we voltages on devices correct. They are correct. You know, it could be a software issue, or maybe the GA, well, I figured out that the masking is slightly by GA. Let's make this easier. Yeah, so that GA can go bonkers. Potentially in the light would die, but most maybe can. A whole bunch of screws. Let me see. I'm curious to see how it's actually doing this. Also, probably a chance to clean this out because it's a little bit dirty. There's a lot of stuff to do, probably smooth. So my table. Okay, so moving on to this one. This is PSB. Okay. Yeah, so screws everywhere. Slowly. Unsure resin. Alright. Okay, so there's also here. LEDs in this area. I'll show you this also. So here's LCD and the power button. Where's the one here? So we'll need power button. Let me unscrew it then. Shit. Yeah, the power button will be challenging right here. Well, so let's see if you're power button. First is X on the ports. This is like this translate file. Okay. Ew, that's getting cleaned up as well. Let's do it here. Okay. That's gonna be challenging. Probably okay, yeah. We need this down here. Install it. Solid. Oh, I see. Nothing goes. Oh, that's actually just maybe just solder. Yeah, I will solder this also. Okay, chunk. Okay, so here. Kitchen is down. Okay, let me. We can put somewhere. And just. Okay, that's all. Then we'll fix it later. Oh my god, look at this. It has a lot of this. Liquidy kind of. Yeah, it's just okay, so this might work. Oh, looks like some other challenge. There's some other things around here quite big. So a little challenge to get access. I know. Yeah, but it's not just ammo. So that ammo people. It's something special also. So yeah, well, something special stuff. Something board. Screw. A free board. So two screws here. Shit, I'm just going to the board needs to be. This is a kind of USB cable. Okay, so it's connected. A whole bunch of wires coming into the. Yeah, from the other this don't understand how to put together. Yeah, it's a good idea. There are things before taken apart. Okay, and also there's crap everywhere. Yeah, I don't have this whole motor, so like sort of like now I'm using it's already sitting everywhere. That's the nature of these. So that motor, I guess this is that probe. I'm using some. Well, still right here to help me. Free. This is that connector. And this one actually sits pretty well. Is connected right? No, yeah. Huh. Take that pen. Oh, this one's actually stuck good. Yeah, that's because it's not so much better than out of this. So that's it's small emission actually and they connect back. Okay, well, comes that motor. Which probably might have the same issue. Which might actually cause everything. So this is not supposed to move around too much. This is the same, but it's usually they have the same. Oh, maybe initially, maybe they were taking more off. Okay, that's good. I'm gonna use some rags. Look at this. It's leaking here. Okay, now let's lower. We'll just do this one. Still use this shit. Oh wait, yeah, let's do this. It's just add it. Oh, fuck you. Sorry. So those screws here. Just lower. Okay, what is this? It says. So, where is this one? This fan. Okay, so check again. Now is that so I'm not sure if you anything. That's the video. Let's see. Get down to the brown one. Show this one. LED minus. Okay. This is that. Next one, LDF plus. There is LDF plus. Next one is LDF minus. Okay, so next two is the fans. Let's mount it because over here. That's the stuff that nothing else. And I'll clean up and take a keyboard. Alright, I think we are good. What the hell? Is that for you? Oh, this is wire. Right. So we have board out of the case. Alright, so the rest of the stuff is so we have a LED power supply, just focus on the main brand. Oh, 2 voltages. Really? Huh. 12 volt 27 volt. Okay, that's interesting to double check. 12 and 27. That's interesting. I'll take a look at that. Okay, so I'm going to move now. I'll check. This is important. Okay, just want to check this off. Okay. Alright, so here we are. So I guess 12 volt is for board here, and 24% volt is for the. That was stupid of me. That was stupid of me. Fuck. I hope this is still alive. Otherwise, it's going to be very not cool. This is external. I think we can have external drivers, yeah, but just read the casing out. I can put the back on. Okay, so this is our first screen. Let's pull the actually over. Let's do this graph. The last to the back. This one check because on the other side. Okay, so here is the other side. Here's this missing here. Something kind of big is missing here. Yeah, it's kind of unfortunately, it's not made unfortunately. So it's very hard to do a data as this does make. So yeah, this MOSFET actually drives the LEDs, right? This MOSFET drives the fan, and MOSFET. Everything else is not 12 volts. Here's like the footprint for I think it's using. Maybe it's used for that. I don't know how this. What is this about? Wow, it's interesting. Unless it's use different ECU or main processor. There's a serial access right here, program. But there's Wi-Fi there. That means just we'll do it here. This Wi-Fi essentially is a serial, so it's a serial Wi-Fi device. Yeah, so this is external set. Actually, if I have issues with this GPUs based on driver, I can connect the external one with something better. So to use this is the box. This is the original screen. So I believe this is still made okay because actually use nothing in the switch first place. So just pop it back in here. Okay, this is not necessary at the moment. So here we can install the wire out. Touch screen just become obviously surrounding, so it's crashing the light and the original display. It's not still holding. Yeah. Fortunately, that's not really where pro voltage display. So this might be about to start. Alright, so we have our setup right here. So we have power supply with 12 volt. Let's just connect. This is negative. Polarity obviously is super important. This is positive. Okay, it's booting. It's consuming right now 146 milliamp. It's already on. Go system back. Oh, it works. Tools. Calibrate. I'm just not gonna see much. Just want to see what's gonna happen. Obviously, it's not showing anything. It's just black. It's completely. It's like essentially completely masking everything. Okay. So now we will have to just go and measure voltages around. Which I don't know where and what, but you would have to figure this out. Another possibility is to actually measure voltages right on this display. Right on this, like I saw some electronic componentry here. Let's take me something plasticky. Okay. That could be somehow, it's all dirty of course. Maybe I can measure some voltages here. Okay, yeah. I don't know how and what I'm gonna measure here, but it's a possibility. It's very not, oh, it's a bit awkward. Look at this crap is everywhere. Okay guys, so I have taken apart all this and now I'm trying to poke around to understand if there is a proper voltage applied to this screen or so. So there are, notice there are 3 voltage regulators right here. So this one, and this one. So not really sure about this one. What exactly is this? It is XL2996S. Also, I kind of looked up this XL2596S, which is turned out to be a buck regulator. This is buck regulator. This is linear regulator, which is set to 3.3 volt, and this is another linear regulator, which is 1.8 volt. Okay, we're gonna measure all this. So also, I got some little bit more info on that stupid screen because it's really hard to find something. So this is like a drawing of it, and also there is some kind of pin out a little bit here, but there is a better kind of table with pin out. So what are you gonna check? So we're gonna check voltages. So 3, 4, we're gonna check for this. There is even a horizontal synchronization signal. We're gonna check for this MIPI DSI data lines. I'm not sure we're gonna see there. And there is should be 4 of them. Should be 4 of them. Let's just count. Okay, D0, D3. And there is a positive and negative, so actually 2 of each, D0, D3, D0, D3. Okay, then we have to find D2, D2, and D1, D1. So yeah, here's the clock. So we can check positive and negative clock, so we can check clocks. I'm not sure we're gonna see much on these D lines, maybe to see if there is some kind of activity going on there. Then this is all unused. Reset pin is unused. We're gonna check these two voltages. This thing doesn't have backlight, right? It's just straight through. So these signals probably gonna be grounded or floating. I have no idea what's gonna happen here. But this is like power supply for backlight, and the backlight driver. We don't have backlight here. So backlight is absent. So I'm not sure we're gonna be here. So a bunch of them are ground and open, which is good. So because it was kind of scary, it's like, I can imagine like whole 50 of them. No, we have only like 8 data lines, 2 clock lines, 1 horizontal synchronization. There's no vertical. Should be? It doesn't need to. Usually, you know, like in video signal, have vertical and horizontal. But looks like no. 50 is open, 49. There's something. Connect to VDDI in PFC. I don't know what that's really supposed to mean. In PFC, FPC, whoever it is. Oh, MPU. I don't know what that's supposed to mean. MPU. Okay, so let's start probing. Well, let's first of all check our voltages. Okay, and then let's go with the poking around the MIPI connector. But first we check voltages because MIPI connector is on other side. Okay, before I'm gonna power up the power supply. By the way, I tried to clean up this gunk from here using alcohol. It is pretty much impossible. This sticky goo is still there. It's like full of it. Oh, disgusting. So that's why I'm still using the my gloves, because it's so kind of disgusting. Okay, so here's my multimeter. I'm probably gonna prepare it, put it right here. Here's the voltage. Okay, so with the 12 volt, we're applying 12 volt again. Is it booting? It is booting. All right, it's pretty quick actually. So we can just connect ground to here, I guess. And don't bother with it. All right, so V in and V out. V in is 12 volt. V out is 5 volt, which is expected. This guys, I think is center one is 3.3 volt. 1.8. So we have all this. Yeah. Oh, I wish I had the schematic of all this, because it's so hard to trace it without a proper schematic. Like have to. Otherwise, I would be able to, you know, poke around this kind of contacts right here on this FPGA, but because I can't, I don't know what are they, those signals. 3.3 volt here, 3.3 volt, whatever. Oh, it's just probably. Yeah, whatever it means. And not that many test points right here, okay? So this is another kind of annoying stuff. Oh, by the way, kind of interesting. Over here, we have unpopulated stuff and pins. Looks like this connect header or unpopulated header is actually going to the FPGA. Maybe we can do something about that. Okay, we have to actually turn it off. Okay, let's just turn it off. Let's remove this metal thingy. Okay, let's just turn it around. Okay, so what I have prepared here, let me a little bit zoom out here. Okay, so here's the screen. I'm gonna kind of poke around here when I do exposure. Can I go back to exposure mode? Go calibrate again. I'm gonna put lots of seconds, like a minute or so. Oh, there. Next. Okay, obviously there's nothing happening, but in the meantime, I'm gonna use my left hand to try to measure here some stuff. Oh, there is my multimeter to show you. We have minus 5.9 volt. I'm sure those voltages are applied, like, regardless. Yeah, 1.8, everything is good. I'm gonna hide it from the light. You see it, no? Okay, what other signals we have? Some kind of... So yeah, the voltage is actually properly going to the board, to the screen itself. Okay. So next step would be use something different. Not sure if we're gonna fit on the screen on the bench. Oof. This time I'm gonna be this. I wish I had tiny one. Okay, we have prepared an oscilloscope, and now I'm gonna see. Let me see without first giving any kind of signal to it. Oh, let's see what we have here. It's 1 volt. I'm gonna reduce it a little bit. What's this? Yeah, okay, I see it's like crop. Doesn't change. Doesn't change. That's 60 hertz though. No. I think 60 hertz here. Get it. After poking around for a while, actually, I found very interesting discovery. Turned out to be, after looking at the different firmware, that it really dependent on the screen which is connected. All right, so this particular guy is DXQ608. And I also was brave enough to actually peel this screen from the device. So this was installed. That was given to me as a broken one. This was installed. In this case, in this one says PJ3608. Turned out to be those two guys have different firmwares for the FPGA, which drives the screens. So let's see what we have here. So there is go system information. So this one says whatever, it's a firmware. First of all, I think there is a newer firmware. V440 LCD KM blah 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 F whatever 1118, whatever it means. Okay, and then go print, because I have downloaded firmwares on this flash drive. So one firmware I have is for PJ608, and another firmware I have is for PJ608 too. Oh, this is the one. Okay, never mind. Then another firmware is for DXQ04, which is this guy, I believe. So let me flash this firmware. Go. So this particular file, V3, this is the board version, V3. So this is G2 box or G2 board V3. Like really hard to tell which is, if it's V3 or not, but over right here on the text it says V3.19. So this is like version 3 revision 19. So in order to flash your firmware, particularly on these boards, you have to pick a file. This is the extension CBD, and this is apparently for the FPGA. And let's just flash it. Confirm, and that means I have to restart the board. I just like boom, boom, just gonna yank the power and restart the board. Okay, it's booting, successfully booted up. Okay, let's see what kind of version we have. Now it says yada 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 F2.21. So as far as I understand, the firmware which was there is newer, this is older, but this particular firmware is for this screen, like 100%. Okay, so let's just test it. Calibrate, next, and we see nothing. So that just gives me clear understanding that it's not firmware issue. That firmware is fine because it's supposed to match this particular screen. All right, let's go back to the print. Now let's go into PG608 firmware, or PJ. All right, we're not gonna touch this update LCD. We're gonna touch this, which says V3, very important, 6082 PJ6082K F11.18, which I believe is newer version. All right, let's go. Flashing it. It's cool that this FPGA is reprogrammable. Now we have to let's just hit reset. There's a reset button right here. It's gonna be equivalent to yanking the power, I'm pretty sure. Okay, let's do system info. Oh, I was wrong. Huh. Okay, let's yank the power. Looks like reset is just for the ARM microcontroller. System. Okay, now it's F11. Okay. It's very important. You have to actually power cycle the thing. Okay, let's try now. Let's see what's gonna. Well, it's no point to try because that was not working. Tools, calibrate, next. Nothing happening. All right, so it is completely opaque. Okay, let's shut it down. So now we have this particular screen. By the way, in order to remove this screen, I have a trick. A trick was actually take this and warm up around the perimeter of the screen, and it just came off very, very easily. No problem whatsoever. Yeah, I don't have to really hit it like crazy, but it came off super easily. So it's glued with this kind of strips, which I would be cleaning up for sure, making sure this is all nice and clean. I will come and I will reapply these glue strips. I have plenty of different kinds, so that's not going to be a problem. So now let's remove this one. Is shut off. All right. Let's attach this guy. Okay, it's booting. Okay, obviously the version gonna be this, so not the one. System info, it's nothing changed, the same version, screen is different. Now let's go tools, calibrate, and do next. Do you guys, wow, you don't really see it. Wow, that's crazy because I see it very well. Okay, let me I don't know how would I show it again. Let's do it again. It's not visible. Let's use a phone as a background. You see what I see? So this thing is working. Hello. Anyways, my point is that with proper firmware, proper screen, apparently there is a big difference between the different firmwares for different screens. And this screen is actually legitimately busted because with its proper firmware it was not working. So this is definitely busted screen. This is working screen. Okay, now when we have this supposedly working, we have to put it all together. But before we put it all together, we have to clean up all this stuff. I'll show you something. Look at this VAT. Okay, first of all, it's super scratched here, so that definitely has to be replaced. But also, it's all covered in this sticky residue. So now I have to think about and figure out how do I clean up all this gunk. So I have no idea at the moment. And probably this is going to be in separate video when I think about how to clean it up and clean up all this to make it look nice. Maybe also replace this fab, because I already ordered some. Also, the rest of the machine is actually pretty dirty too. Like, even I'll have to obviously reattach this heatsink. I hope I didn't bust that guy. I reattached the heatsink. All this gunk has covered in some kind of goop. So all this has to be cleaned up. This display has to be cleaned up. I'm gonna put it all together, and then we're gonna test the 3D printer with you. But for now, I think we have a success. We figured out the proper way of using a proper firmware for this particular screen, and now it's actually working. I also would like to update it to the very latest firmware, but so far, so good. So guys, I think this is going to be it for now. This is going to be part 1. We are kind of analyze the problem, we figure out the solution, and we fixed it. Next, let's just put it together in nice and good shape. So thank you guys for watching. See you next time. Stay safe and ciao.